set of video tutorials before our Zoom will start after you've completed this task. And in this set of video tutorials, what I'm hoping to do is to make sure that you all understand how the ATP PC system works at that molecular level and how the energy comes from that phosphate creatine we've spoken about in terms of resynthesizing ATP or putting ADP and P back together. So I'm going to show you a diagram from the textbook now, and that diagram looks like this one here. In this diagram, you'll notice that we have creatine phosphate, phosphate creatine. Those words are interchangeable, whether it's CP or PC, it doesn't matter. But this bit here that I've highlighted is a standalone entity. And very similar to what I've shown you with how ATP allows the bond to break, the same thing happens when the creatine and the phosphate, which becomes inorganic, is allowed to break that bond and it releases energy. So we had adenosine triphosphate. The adenosine triphosphate became adenosine diphosphate and the inorganic phosphate when we used that energy for movement. So now if we put the energy between the creatine and the phosphate bond back into this gap in the ADP and P, we'll notice this arrow says that it becomes ATP once again, and we can use that ATP for more energy for movement. What I would like to do for you is draw this, and then I want to hop on the exercise bike behind me and talk you through what is happening at the muscle site during my cycle. And remember, it has to be done at a high intensity in order for the ATP PC system to be the dominant system. Because if I don't cycle at a high intensity, my oxygen demands will likely be met. And so therefore, my body will have no need to rely on the phosphate creatine for quick ATP resynthesis. It will use an aerobic system where it won't fatigue and it can take its time using the oxygen to provide me with energy for ATP. Let's have a look at this interactive diagram. We've got adenosine triphosphate sitting inside our muscle. We've got lots of them. There's not one, lots of them. And the muscle starts to move. And so this bond is allowed to be broken or released. And we know that what happens is that that releases that energy for the high intensity for my muscle to be able to contract. We've spoken about that many times. So there's a gap here now, and that gap is missing energy because the energy was used to move a muscle. So once that happens to all of the stored ATP in a muscle, if we want to continue to move our muscle, we're going to need to put energy back into this equation, which is now adenosine diphosphate and the inorganic phosphate sitting on its own over there. So what we do is sitting inside our muscle are some creatine phosphates or phosphate creatine, as I mentioned earlier. That's 1 part creatine, 1 part phosphate, bonded together, very similar to the way that the ATP was bonded together before. And the brain starts to tell the muscle, I need more energy. Where am I going to get this energy from? I need more ATP. And it allows that creatine phosphate to break its bond. And the same thing as holding that bottle I spoke about in class the other day, that bond that was high energy now releases energy. And when it releases that energy, it takes that energy back into the broken part of the ADP and P equation. So that line there that was holding creatine phosphate together, that energy is transported up and puts ADP and P back together. Once the ADP and P is back together, we can go through this same process of releasing that bond to move our muscles with that energy again. So if we have lots and lots of stored creatine phosphate within our muscle, we can continue to use each of these bonds to release, to release, to release, and resynthesize ADP and P back into ATP very, very quickly. But the problem with this energy system, we don't have a never-ending supply of creatine phosphate. It runs out, and when it runs out, we need to rely on another system to put ATP back together. Exercise bike. And on the exercise bike, I'm going to perform some high-intensity cycling. Remember that it has to be high-intensity cycling, otherwise the ATP PC system is not going to be the system that becomes the most dominant system. So, while I'm sitting here, the muscles that are going to be used in my legs already have some stored ATP in there. So when I do my first 3 seconds of hard, high-intensity cycling, the stored ATP is going to be used. That third bond will be broken. That energy will help move the muscles. But after 3 or so seconds, once all that stored ATP is gone, my body is going to rely on an energy system that's there, it's quick, it's easy to use, and it's able to put ATP back together, resynthesis, very quickly. So it finds the creatine phosphate and it starts breaking them apart and using the energy that was holding the creatine and phosphate together to put ADP and P back together, which allows that new ATP to move the muscle. So here we go, I'm watching the timer here and I'm off. And I'm high intensity and it's been a few seconds, and so my stored ATP in the legs, in the muscles, is starting to be gone, and so now the creatine phosphate is trying to find its way. But this is only going to last me for about 10 seconds, because now the body is starting to learn to huff and puff, because I'm going to have to find another energy system to be able to produce the energy to put ADP and P back together. So while I was on that bike there, what I would like you to do on your task, once you've drawn the diagram for how the ATP PC system puts ADP and P back together, I want you to talk about what happened while I was on that bike. Talk about high intensity, talk about stored ATP, and then talk about the ATP PC system putting or resynthesizing the ADP and P back together to make ATP for more muscle contractions.